problem 1, letter C. We have a slightly different looking series than the first couple that we did. From n equals 0 to infinity of n factorial over e to the n squared. But before we start working with this, I want to be clear that e to the n squared is very different from e to the n quantity squared. Remember that this is equal to e to the 2n. This is saying we're raising e to the n squared power. So anytime you have factorials, that should be the sign that if you're going to test it, you got to use ratio test. So we're going to use the ratio test. And remember, for the ratio test, we're going to take the n plus 1th term. So here, we got to be careful. We're plugging in n plus 1 instead of n. So we get e to the n plus 1 squared times the reciprocal of the nth term, because we're dividing by the nth term. So this would be e to the n squared n factorial. So let's think about what cancels out. And remember, if this converges, this quantity needs to be less than 1. So n plus 1 factorial over n factorial is just n plus 1. The e part's not so obvious. We need to do some work here. So far we have n plus 1 e to the n squared over this. So what we're going to do here is FOIL out this exponent here. So n plus 1 squared is n squared plus 2n plus 1. So that's all the power of the e, due to us doing n plus 1 quantity squared. And remember that if you have a sum in the exponent that corresponds to different exponential terms multiplied times each other, I'm just going to go ahead and drop the absolute value because n is always positive and exponentials are always positive. So that means on the bottom we could write that as e to the n squared times e to the 2n times e. Because we have powers of n squared, 2n, and 1. When you multiply those, you would add the powers and get back to what we had here. But the reason we want to do this is because now we can cancel things out. E to the n squared, e to the n squared, those go away. The rest of this does not. We're left with n plus 1 over e times e to the 2n. And remember, we're taking the limit as n goes to infinity. Should have written that over here, actually. So now we need to take the limit as n goes to infinity of this. Just by knowing how these functions work at this point, once you've done all this, or if you're still having trouble seeing that, by using L'Hopital's rule, exponential functions kill n plus 1. This is going to be 0. Because our bottom is infinitely larger than the top as n goes to infinity. So we were using the ratio test. If we got something less than 1, then this would converge. We did. So this converges by the ratio test.